Good afternoon, everybody, and I'd like to thank you for joining us. This is Jack Stewart from the Viavi Solutions EMEA marketing team. Just like to take this time to thank you for joining our webinar today on the ADS-B testing best practices. We've got a lot to share with you, but before we begin, I'd like to let you know a few things about the format that we're going to be following. So the webinar is being recorded for you to review or share with your colleagues. You will receive that in approximately 24 to 48 hours. We will send an email to all the attendees with a link to this recording. All lines are currently on mute, but we are monitoring the chat window and will try to answer your questions at the end of the webinar. If we are unable to do so, however, we will reach out to you individually to ensure that you get your answers that you're seeking. And now I'd like to turn over to our speaker today, Hamish Stewart.
Thank you very much, Jack. Hi everyone, this is Hamish Stewart and I'm a Business Development Manager for Viavi Solutions, and I'm joined today by my colleague Barry Beasley, who is an Avionics Product Development Manager. During this webinar, I'm going to give an overview of the following. Firstly, ADS-B technology in terms of what it is, the benefits that it brings, and how it's developed over time. I'll then talk a little bit about the EASA mandates covering ADS-B transponders and what the recent changes to that are. The bulk of the webinar will be about the things that you should be aware of when testing ADS-B systems and what we and many of our customers believe to be the testing best practices to follow. I'll then give a brief introduction to the Viavi products, which can be used to ensure safe, reliable and efficient ADS-B testing. If you have any questions throughout the webinar, remember, just put them in the chat window and myself and Barry will endeavour to answer them all at the end of the session. In the event that we don't have time, we'll follow up with you via email to ensure that you get the answers that you need. Before I go into that though, I'd like to give you a quick overview of who Viavi Solutions are and why we're qualified to talk about avionics testing. Viavi Solutions, created from JDSU, was founded in 1923 as Wandel and Goldman by two technicians building and selling radios. Through investment in R&D and the acquisition of key technologies and other companies, we have grown into one of the world's largest electronic test and measurement companies. With the acquisition of Cobham's Avcom division in 2018, Viavi catapulted itself to the forefront of avionics testing. Cobham itself had acquired the Avcom business as part of its 2014 purchase of Aeroflex, a name synonymous with the avionics industry that can trace its roots back to the company's JC Air and IFR systems. The Avcom business is still in fact based in Wichita, Kansas, where IFR started, and many of our current Avcom employees have been with the business for decades. So now that you know who we are, let me give you a brief overview of what ADS-B is. ADS-B is a modest transponder-based surveillance technique that relies upon aircraft or airport vehicles broadcasting their identity, position, and other information derived from onboard systems such as GNSS receivers or altimeters. The signal can be captured for surveillance purposes on the ground, that's referred to as ADS-B Out, or onboard other aircraft, referred to as ADS-B In. The latter can facilitate airborne ground situational awareness to aid spacing and separation of aircraft. The A within ADS-B stands for automatic, because unlike previous transponder technologies like Mode A or Mode C, no external stimulus or interrogation is required for an ADS-B transponder to transmit its signals out. These unsolicited downlink transmissions from an ADS-B modest transponder are referred to as squitter. The D in ADS-B stands for dependent, because it relies upon onboard systems to provide surveillance information, the S in ADS-B, to other parties. Finally, the B in ADS-B refers to the fact that the data is broadcast, i.e. the source transponder itself has no knowledge of who receives the data and there is no interrogation or two-way contract between it and the receiving device. ADS-B is seen as a key enabler of the future of air traffic management networks, contributing to the achievement of the single European sky performance objectives, including safety, capacity, efficiency, and environmental sustainability. So what do we mean by greater efficiency from an ADS-B transponder? So efficiency savings can be achieved both on the ground and in the air for aircraft that are equipped with ADS-B transponders. At airports, a locally optimized mix of available technologies, i.e. airport multilateration, surface movement radars, and ADS-B Out will enable advanced guidance and control for optimized aircraft spacing that can be part of an integrated airport operation. In the sky, if an aircraft is equipped with ADS-B In and a means to effectively display available surrounding traffic information to the pilot, then airborne self-separation can be optimized and pilots can have better situational awareness. In terms of increased safety, the enhanced level of shared data that ADS-B enables allows pilots to more accurately assess the position of other aircraft and receive real-time warnings or redirection. This creates a significantly improved safety profile, with callouts no longer subject to latency constraints and error levels are minimized. ADS-B can also monitor air traffic at very low altitudes or on the ground, so inadvertent runway incursions become appreciably less likely. There's also the ability to provide advanced information. So in addition to real-time weather reporting, ADS-B In also provides other supplementary information for pilots, such as runway closures, flight restrictions, and terrain maps for low visibility areas, all of which further augment the safety and efficiency of ADS-B enabled aircraft. As I mentioned earlier, ADS-B is a Mode S transponder-based surveillance technique, and the table here shows how Mode S transponder functionality has changed over the years. It has gone from being a basic interrogator-based system reporting things such as altitude and aircraft codes to an automatic broadcast system which allows much more information to be reported to the ground and shared within the sky. Now, ADS-B has existed as a technology for many years, as many of you will know, and as you probably know, it's used within Europe and around the world. It's in use within Europe and around the world already. Now, different regions and countries have mandated the use of ADS-B transponders on aircraft flying within their airspace at different dates throughout the last few years, and the table here shows the status of each of these. You will see that within Europe, the deadline for implementation of ADS-B within specified aircraft is now the 7th of December 2020, a recent change to the original date, which was the 7th of June 2020. Within Europe, EASA, the European Union Aviation Safety Agency, develops common safety rules at the European level, and it monitors implementation of standards. Their certification specifications for airborne communications, navigation and surveillance, known as CS-ACNS, which were originally published in December 2013, have a section 4 which details the requirements of the ADS-B extended squitter messaging. In terms of which aircraft these regulations apply to, all aircraft weighing more than 5,700 kilograms, or all aircraft that have a maximum cruise speed of greater than 250 knots have to be equipped with ADS-B Out equipment. The original date for aircraft to have this was 7th of June 2020, but this has recently changed to be 7th of December 2020. There are some transitional agreements and exemptions to that, as detailed in the table shown. Notably, in terms of transitional agreements in place, any aircraft which had its first certificate of airworthiness issued between the 7th of June 1995 and the 7th of December 2020, and which is part of a retrofit program, means that it will be compliant, which means that it will be compliant by 7th of June 2023, are exempt from this 7th of December 2020 date. Exemptions are also in place for aircraft with a certificate of airworthiness which was issued before the 7th of June 1995, or for aircraft which will be retired by the 31st of October 2025. Quite often, the European mandate is compared to the one in the USA, which came into effect at the 1st of January this year, and there are some slight differences between these mandates which are shown in the table here. These may be relatively minor differences, but they are important to be aware of if you are involved in certification or testing of aircraft which can be flying between both continents. So what does this all mean in terms of the aircraft within Europe? So the number of aircraft that this affects within the European fleet is roughly 7,500. And the good news is that around 5,250 or 70% of them are already equipped. That does mean, however, that over 2,000 aircraft still need to be equipped with ADS-B. Out of those still to be equipped, it's estimated that around 10% of them will fail the initial testing after the equipment is installed. So efficient testing is an absolute must if you want to ensure your ADS-B installations are safe and secure. So before I'd like to move on to talking about the best practices, I'd like to remind you to submit your questions via the chat window that we will answer at the end. Also, we have a quick poll question for you to answer just now. Jack, can you launch the poll, please?
Yep, just launched the poll there. So just asking you quickly that if you were aware to the changes that have been made to the EASA ADS-B mandate, and if you could just choose yes or no. So far got around 30% of audience voted, so we'll just give you guys a couple of minutes to get your votes casted in. Yeah, that's us reached 60%, so I'll just give you another few seconds just to get your last minute votes in. Okay, so as we can see there, around 55% of the participants here knew that there was changes to the EASA mandate, but 45% didn't. So that's good for us to hand back over to you there, Hamish.
Okay, thanks for that, Jack, and that's good to know that at least at this stage we've hopefully some of you on the webinar have learned something particularly about the mandate. So I shall move on. We shall, sorry, skipped ahead there. I'm going to talk about the ADS-B testing best practices. Now, these are things that we deem to be essential to ensure the safe, reliable, and efficient testing of your transponders. So first of all, there are a couple of things that you need to do before you start testing. One of the most important things is to consult the aircraft maintenance manual for the aircraft that you're testing. Particularly for wide-bodied aircraft platforms, these can have many different testing requirements, and the aircraft often needs to be put into a specific mode for testing. Similarly, there are regular 2-year maintenance testing cycles mandated by EASA, and the schedules for these are in the ACNS documents for retrofit of ADS-B transponders. Also within some of the EASA documentation is the appendix to some of the safety information bulletins that are out there. So with particular identification of the Appendix 1 in Safety Information Bulletin 2011-15R2, you can see that that mandates that that recommends that you contact a local air traffic control unit and advise them of your intention to conduct transponder testing. So when you're doing that, you'll need to tell them the start time and the test duration, and you'll also need to inform them of the altitudes which you'll be testing, your intended aircraft identification, and what your intended Mode A code is. So all of this needs to be done before the test. And then most importantly, what you will need for transponder testing is a transponder test set. And to test these installations and to ensure that the system performance is as required, you will need a transponder test set which has the option to test ADS-B out specifically. there will then be various checks done to perform that your equipment is specified within the test equipment to determine any non-performing issues. Doing this will ensure that you have safe, reliable, and efficient ADS-B testing. Things to look out for when you're doing the testing are such things as missing data, and that can be data from the subsystems within your aircraft that feed into the transponder, or something within the qualification of the data that means the transponder does not send it on. The next group of things that we want to look out for are GNSS integrity and accuracy issues. And it's important to note that when you're talking about GPS signals and talking about the signals that are reported out of your ADS-B transponder, they're not always called the same thing in GPS terminology as they're called in transponder terminology. Other types of things to look out for are where installations may have gone wrong. And that could be something as simple as the address being wrong because some pins have been set incorrectly within a transponder. It might be a flight ID mismatch, typically caused by pilot data entry errors, or it could be missing Mode 3 or Mode A codes. And there's also the issue of the aircraft on the ground, i.e. not reporting that it's on the ground correctly. And again, this can be caused by switches such as those on the altimeters not being in the airborne state when the ADS-B testing is done. So first of all, you want to set up your transponder, and there are some general points that you should look out for when doing this. In terms of the antenna that's being tested, quite often there will be antenna either on the top or on the bottom of the aircraft, so you need to specify which one you're using. In terms of the RF port that you're connected to, there are a few ways of connecting to this. So you can either use a tester, which has an antenna, and you can be testing over the air to the antenna on the aircraft itself. You can be directly coupled to the transponder connection on the aircraft antenna if you've removed the antenna, or you can have the antenna on the aircraft in place and you can connect to that direct with a coupler. You also need to note what the antenna range and height is, specifically if you're using a test set with an antenna to connect over the air to the aircraft, you need to be within the range of it to be operating correctly. And then also, if you're using a direct connection or a connection with a coupler, it's important for you to specify the cable length, the cable loss, and even the coupler loss if you're using a coupler. The next thing to look out for is the UUT address. Now, if you're within testing distance of a number of aircrafts and you're performing over-the-air tests, you should use the UUT manual addressing mode, and that avoids you getting multiple replies to the test calls from the test set when you send out the all call acquisition message. And you have to note that the aircraft within the test area need to be in the airborne state for testing. So again, you will need to refer to your aircraft maintenance manual for that information to ensure that your aircraft is ready to test, as well as your transponder tester and your transponder being ready to test. Often, the parameters that are to be tested are spread across a number of different binary data store registers. Also note that the geometric altitude is referenced from the GNSS signal received and is referenced to mean sea level in the area that you're performing the test at. One other thing to note when you're doing the ADS-B testing is that you need to calibrate the barometric pressure gauges on the aircraft before you do the aircraft testing. On some testers, there's an auto test screen that allows you to test all of the parameters required by the regulations and give you those in one nice simple screen to allow you to tell if the test has passed or if it's failed. And for the EASA tests that are mandated, we've got an automatic test on our equipment that gives you coverage of about 95% of the testing all in one place, and the other 5% can easily be accessed on a couple of different screens within the tester. One of the things that often fails is the power and frequency that's coming out of the transponder. Now, this can be due to a number of things, such as improperly being set up. It can be due to multipath or reflection issues within the hangar or the environment that you're testing. And it could also be that you've got the antenna gain parameters set up incorrectly. Now, the best solution to avoid this type of issue is to use an antenna coupler, which washes out the antenna gain and takes care of any reflection or multipath issues which you may be seeing. So the use of antenna couplers ensures safety whilst you're testing, because it shields that RF transmission from the aircraft, and it ensures that it's just that signal which is going into your test set, and it ensures that the signals going from the test set are the only ones which are going into your aircraft. Now, this is actually advised by EASA in Safety Information Bulletin 2011-15R2, and it's also advised by the FAA in SAFO 17002. Now, why is this specified or advised within these documents? Well, essentially, this is to ensure that you have no false intruder situations. So you will see here on the bottom right-hand side of the screen, you've got your hangar where you have your aircraft that are being tested. Now, typically this will be close to an air traffic control tower, and it will have aircraft flying overhead. So with the proper use of couplers to do the testing, that essentially shields your aircraft on the ground, and it stops it from appearing as if it's in the sky as a ghost aircraft. So if that ghost aircraft appears in the sky when it's actually on the ground, that can cause problems for both air traffic control and for other pilots. And you can see here that in EASA Safety Information Bulletin 2011-15R2, in Appendix 1, it actually recommends the use of transmission covers whether or not testing is performed inside or outside of a hangar. So going back to other things to look out for when you're testing ADS-B installations. So the aircraft GPS needs to have a clear view of the sky or the GPS constellation to generate a good horizontal protection limit NIC value. Normally, testing results inside a hangar are not acceptable due to satellite blocking and multipath. So there are ways of getting around this. You can either move your aircraft outside the hangar, or you can use GPS repeaters within the hangar. Another way of doing this, or avoiding these issues, is to use a GNSS simulator. And this can be a cost-effective alternative to using a live constellation or to having to go to the cost of moving your aircraft outside of the hangar to a known reference location. So when it comes to GPS simulation, how does that ensure a reliable test? Well, the first thing is it allows a user to generate a reliable static GPS signal whilst not in direct line of sight of the satellite systems, i.e. inside the hangar. Coupled with that, it also allows the user to simulate flight path information to perform dynamic testing for checking latency issues within the transponder system. This also allows you to show that the GPS on the aircraft is working at various locations and not just in the one where the aircraft is positioned whilst doing the test. And again, it also eliminates the GPS repeater errors, which can be seen when you're using the aircraft in a hangar on a surveyed location. When working with GPS simulators, it's important to note that the naming conventions used by GPS systems and those by ADS transponders differ slightly. But the key things to note for both are that GPS accuracy and reported accuracy are the things that you should be looking out for. GPS accuracy is dependent on a number of factors, such as the user equivalent range errors, including ionospheric defects, ephemeris errors, satellite clock errors, multipath errors, etc., and satellite geometry. And all of these are line of sight errors. Now, when it comes to reported accuracy and integrity, which for GPS receivers which are not SA aware, the accuracy and integrity reported and then used in ADS-B messages is based on an assumed value of UERE corresponding to the period when the SA was active. This value can be grossly larger than the accuracy of the positional data delivered now that the SA is inactive. So it's important to be aware of all of these things when you're testing your transponder to ensure that your GPS accuracy and integrity is reported correctly. And the use of a GPS simulator is the best way to do this because you can have control over all of these parameters that are going into your transponder so that you know exactly what they are and you should know exactly what they should be when they come out of the transponder. One other thing that can also be used to ensure efficient ADS-B testing is automation software. So in terms of automation software, this can reduce the test time because often the ADS-B testing involves setting up lots of things manually, both inside the aircraft and on the transponder tester. And if you can have some software which can automate all of this, that can greatly reduce your test time. In the same manner, this can also eliminate manual errors, which are often experienced by users when they're inputting data into the test set. And again, if you're able to not move your aircraft out of the hangar and do some automated testing in the hangar, it allows you to save on the fuel costs. And finally, by using automation software, you can generate a test report automatically, which again is more efficient. So what would the automation software system look like? So you've got your aircraft or your unit under test, and the first thing that you need is a transponder tester. You would then have that connected via a coupler to the antenna, which is connected to your ADS-B transponder. And again, to make things reliable, we'll just say that we can have a GNSS simulator, and again, we will have that connected to the aircraft via a coupler to ensure that the signals are shielded and not affected by any multipath issues. We can then connect both of these devices up to a laptop or a PC and run some automation software, and that allows us to quickly, efficiently, and reliably produce a compliance report that will show how the ADS-B system has been tested on your aircraft. So before we move on, we'll run another short poll to just see how you are currently testing in your environment. So Jack, can you launch the poll?
No problem. So again, we have our second poll here, which is currently which products does your organisation use to test ADS-B capable transponders? And if you could just select all the answers that apply to you, that would be great. Yep, so we've had around 35% of the audience vote. So if you could just keep getting your answers in, remember it is multiple choice, so you're able to select more than one answer if that is applicable to the way that your organisation tests ADS-B capable transponders. So it's up to around 50% just now, so we'll just give you 30 more seconds to get your last answers in. That'd be great, thanks. Okay, so as we can see by the answers here, we've had 77% of people say they use a transponder tester, 52% saying that they use antenna transmission covers, 20% saying they use GPS simulation, 7% saying that they use automation software, and 13% saying that they use all of the above. So that's back to you now, Hamish.
Okay, thank you very much, Jack. And that's great to see that there are so many of you out there already using the things that we're recommending and are seen as demonstrating best practice for all of the ADS-B transponder testing. And I'd like to also remind you at this stage to submit your questions via the chat window, and we'll do our best to answer them as best we can at the end. Okay, so the next thing we're going to talk about very briefly is the Viavi Solutions ADS-B performance testing products. So first and foremost, something that you may be aware of is that we have the IFR 6000 and IFR 6015 transponder tester. And this is the most widely used flight line tester today. And as you can see from the screenshot here on our website, we have various training videos available on the Viavi webpage of how to use this. And coupled with that, we also have our antenna couplers.
Sorry, Hamish.
And you can see here.
There. Hamish, can you hear? It doesn't seem to quite have updated from the poll. So if you could just quickly unshare and then reshare your screen so that we can see what you're showing us.
Okay, I will do. Okay, are you able to see my screen again, Jack?
Yep, that's perfect, thank you.
Okay, so as I was saying, I'll just talk briefly about the different ADS-B performance testing products that we have available at Viavi. So the first thing is the Transponder Tester. Now we have two versions of this, the IFR 6000 and the IFR 6015. So the 6000 is targeted at the commercial market and the 6015 is targeted at the military market. And on our website, if you go there, you can see some nice how-to videos on how to use the equipment for doing various different tests related to navigation and communication equipment within your aircraft. We also have a range of transmission covers or antenna couplers, which can be used for ADS-B testing, can be used for TCAS testing. And again, you can get full details of these on our website. We have also a GPS simulator called the GPS G1000. And again, like our other products, you can find more information about this on our website, where you'll see application notes, brochures, data sheets, software and firmware release notes, and some technical papers on how to use it and what the technology is about. And finally, we have our automation software called ADS-B Integrity Test Application. And we actually have a free software download for this, where you can download a demo version of this from our website to just get a feel for the types of things that you can test using this in an automated environment. So again, these are the four main products that we have for testing ADS-B compliance to ensure safe, reliable, and efficient. To open the questions up, we're at the end of the webinar presentation. So my colleague Barry Beasley will join me for answering some of the questions that you've submitted. So Jack, if you can perhaps read out a selection of some of the questions, we'll do our best to get these answered for the people on the webinar.
Yep, that's no problem. So thank you, Hamish. I've got a question here that says, what options are needed to make it possible to test an ADS-B in functionality with the IFR 6000?
Just the ADS-B option 03. It has the capability of generating a single target. In the later hardware that we have, and that will be indicated if you've got a mod strike 3 on the unit, that will be supporting our 4.15 software. That has some CAN scenario for target generation. It's a bit easier to set up, but basically you can generate a single target in the ADS-B generate capability of the 6000, and all you need is option 3, the ADS-B option.
Okay, great, thank you, Barry. We also have, does ADS-B only use GNSS or does it also use GPS?
Well, GNSS is a generic term for all satellite-based navigation systems. So within that, you would have GPS, Galileo, GLONASS. On our GPS G1000, we support GPS and Galileo systems. So yeah, when you talk of GNSS, that's just generically all satellite navigation systems.
Okay, that's great. We've got another question here. Does the FAA require annual testing of ADS-B installations?
I believe, and you can find there's some references of FAA documents that cover that, but it's the same as EASA. It's 2 years.
And Barry, what is the main difference of the IFR 6015 military version compared to the IFR 6000?
Yeah, the 6015 has all of the same capability as the 6000, but it has military IFF modes 1 and 2 in the transponder test side. And as well as being able to test DME, it can also test TACAN, including ground-to-air and air-to-air types. So that's the main difference, is the TACAN test capability. Oh yeah, and one other thing, it's got ETCAS, which is an enhanced TCAS used by the military for in-flight refueling. It has that capability.
Okay, perfect. Another question here. Is there an IFF Mode 5 Level 2 test set currently available from Viavi?
Yes, that would be the APM 424 V5, which you can find on our website. APM 424 V5.
That's great. Can we do the upgrade of the 6000 software in our avionics shop?
If it's just a case of putting the ADS-B option, yes. Once you purchase the option, you can be sent an option key file. You put that onto a USB stick. You put it into the test set via the breakout box that comes with the test set. Power the 6000 up. It will see the option key file, ask you if you want to load it. It will load it, and there you have the option. That's exactly the same way you can update software in the field. That you can download from the 6000 product page on the website. Download the latest version of software. Make sure you read the instructions as to your hardware status, as to which there's two versions of software. And then it's the same procedure. You put it onto a USB stick, put it into the unit, power the unit up. It will ask you if you want to upgrade the software. Say yes, and then it's done automatically. It doesn't affect the calibration of the equipment. All of the cal data is held in non-volatile memory, so that's not affected.
Perfect. What are the pros and cons of a GPS repeater versus the GPS simulator?
One of the things would be whether you can satisfy the NIC and NAC figures using a repeater. So you may get a position But when you're doing particularly an installation certification, you need to be certain about about those parameters. They've got to obviously got to exceed the minimums, and sometimes with repeaters you can get distortions that affect pseudo range accuracy, and you may get a position, but it may not be good enough to actually the test requirements. So that would be one of the things. The other thing is that if you use a simulator, you've got control over the RF level. So you can be certain about the sensitivity of your receiver as well. If you're working just on the open sky, or you're working with a repeater, you can't really be certain with regards to your GPS receiver sensitivity. It could be 5 dB down for a number of reasons, and it could still work. But if you fly the aircraft into a northern latitude where satellite coverage is lower to the horizon, you might be losing satellites that you shouldn't be losing.
That's great, thank you again, Barry. I think we're getting to the last couple of questions. Give me 2 seconds. So we have a question here, Barry. I got a shield in the package with the IFR 6000. Why do I also need a coupler?
If you've got a shield, then you would still need to be shielding if you put the aircraft into an airborne state, you still need to shield the antenna that you're not testing through. So if you're testing through the bottom antenna with a coupler connected, you still need to shield the top to make sure that there's no altitude reporting transmitted from the top antenna. So you can do altitude reporting tests by shooting through the antenna. It provides 20 dB of isolation, which is enough, certainly in the hangar, so aircraft outside will not see you, or a traffic control won't see you. However, in terms of when you do the altitude reporting test, then you've got to take the shield off when you do the rest of the tests, like sensitivity and power. Otherwise, they won't be reading correctly. When you use the antenna coupler, that avoids that problem. You can set the coupler up with the correct loss parameters for the interconnecting cable for the coupler itself, and then just carry out your complete set of tests. Another thing is if you're testing on wide-bodied aircraft, a lot now are fitted with ADS-B transponder antennas, and these have forward gain of about 5 dB. And this can be problematic when you're testing. You may have problems with the power failing if you're doing the US procedures to FAA Part 43 Appendix F, and you may have failures with too much power being radiated in the forward quadrant. So when you use the coupler, because it's coupling in the near field of the antenna, you don't realize that 5 dB gain, and it means then you can pass the FAR test without any problem at all. And it's still a perfectly valid of the antenna as well.
That's great. Here as well, can the IFR 6000 test whether the ADS-B system on board the UUT is receiving other targets if the UUT is equipped with ADS-B in receiver?
Yeah, the UAT option on the 6000 enables you to test the UAT transceiver on an aircraft. Most of those systems, of course, are used in the US. The only people using them in Europe probably would be any OEM manufacturing aircraft that might be supplied into the US region. But by and large, UAT is used just in North America.
Yep, thanks for that again, Barry. Just checking through to make sure if there's any other questions we've got. Got a few people asking if we can get the presentation slides. There will be, you will get sent a recording of this webinar, so you'll be able to review the slides all again through that. Okay, we've got another question here, Barry. Is it possible to record and download test results via RS-232?
Yes, you can save test results in the test set, and yes, you can dump them over the RS-232 interface to a PC.
Okay, perfect. And I think this looks like we could be the final question here. Where can we download the software for the IFR 6000?
Yeah, if you go onto the Viavi website and do a search on 6000, or if you just do Viavi 6000, do a search in Google, it will come up with the product page for the 6000. And if you look down, there's some tabs at the bottom of the product page, and I think one of them is resources, and you'll find in there that there's things like operation manuals that can be downloaded, but you've also got software that can be downloaded as well. So it's all done from the product page.
Okay, that's perfect. And looks like this could be the final question here, just to wrap us up, Barry. Is your integrity test locked to a single user, or can it be used on multiple devices once purchased?
Yes, no, there isn't any problem with that. When you buy that option, there's an option key file that goes into the 6000 that's required to activate some software to allow the communications with the host PC. But in terms of where you can run the actual app, no, you can run that on more than one PC. But you'd be limited to using just the one 6000 that has the integrity option.
Okay, that's great. We've just had one more question pop in, Barry, so just before we finish there. Says, you mentioned UAT. Avionics are about to start UAT.
I'm sorry.
Sorry, I think I cut off a little bit there. Yeah. So avionics are about to start UAT broadcast in selected part of the UK. Typically, are many airframes operating in Europe actually capable of receiving UAT, but simply don't use it?
Sorry, many what? You broke up.
Sorry, I'll just start again. So avionics are about to start UAT broadcast in selected parts of the UK. Typically, are many airframes operating in Europe actually capable of receiving UAT, but simply don't use the facility?
Well, that's a question for operators as to what they actually have installed on their aircraft. I can't think of any, as it's a completely separate system, a completely separate frequency it operates on. I can't imagine why anybody would have a UAT transceiver installed unless they were going to use it. So I would say the answer to that probably is no.
Okay, that's perfect. So that concludes today's webinar. I'd like to thank everyone for attending. As a reminder, this webinar will be sent, well, a recording of this webinar will be sent to everyone. It will also be available to access on the Viavi website in around 24 to 48 hours. We're just going to leave you with a quick survey, so if you could answer that for us, that would be great. And again, just thanks everyone for attending, and that's all from us.